In this question, we will locate the centroid of a complex area in which parts of circles are also involved. So this is the shape for which we are going to find out the centroidal axis. That is the x bar and y bar. So we know x bar equal to a1 x1 plus a2 x2 etc. divided by a1 plus a2, and y bar equal to a1 y1 plus a2 y2 plus etc. divided by a1 plus a2 plus etc. So for that we have to find out the a1 area of the first thing, second one, third one, etc., and distance of that particular area from the centroidal axis in the horizontal direction x1, then x2 x3 etc., and similarly y1 y2 y3 etc. Then you can easily calculate this. So first of all, to solve this, what we are going to do is we will draw the reference axis x and y. Then we will divide this into basic standard shapes. We can here divide it into 1, 2 and 3 standard shapes. First one is a semicircle, second one is a rectangle, third one is a triangle, a right angle triangle. The dimensions given are, this is 2 centimeters, this is 6 centimeters, this is 3 centimeters. Okay, so let us start with the first area. The semicircle area 1, and the distances are, this is 2, and what will be this distance? This is the radius of the semicircle, that is 2, therefore the diameter should be 4. This is the diameter, therefore the height of this area is 4 centimeters. Now its centroid will be somewhere here, so this will be the centroid. Okay, then in this figure this will be x1 and this will be y1. This will be y1, that is distance of this area centroid from x-axis will be y1 and y-axis it will be x1. Now we need to find the values of x1 and y1. We know the centroid of a semicircle from its base, that is this distance, will be at a distance of 4r by 3 pi. 4r by 3 pi. So this distance is 4r by 3 pi. This distance is 4r by 3 pi. And the total distance is 2. So we need this distance. This is the distance. So this distance will be, total is r minus 4r by 3 pi will give you this distance. That is that this distance will be r minus 4r by 3 pi. That is x1. x1 equal to r minus 4r by 3 pi. And y1 will be equal to just half of this, that is the radius itself. So it will be equal to 4 centimeters. y1 is equal to 4 centimeters. Okay. Then what will be r minus 4r by 3 pi? R minus 4r by 3 pi will give the equation is 2 minus 4 into 2 by 3 pi. You will get it as 1.15 centimeters. Okay. Then for the second area, is a rectangle with the dimensions as 6 centimeters, and this is 4 centimeters. Its height is same as that of the diameter of the semicircle. So its centroid will be here. This is the centroid of that area, its own centroid. Therefore, x1 will be this distance. This will be x1. And y1 will be this distance. This will be y1. Okay. So x1 is equal to, what will be x1? This distance will be 3 centimeters. 3, and this is, already we know it is 2. So totally this distance will be 2 plus 3 equal to 5 centimeters, and y1 equal to 2, that we know already. Okay. Then for the third area, that is triangle, right angle triangle, we have triangle like this. This is 3 centimeters. This is 4 centimeters, and we know the centroid is somewhere here. It's on centroid. So how to find out the centroid distance? x3. So this is x3 equal to, what is this distance? This distance is 2 plus 6. Okay, 2 plus 6, that is 8. This distance is 8 centimeters. Then plus this distance, this small distance. What is this distance? This distance will be b by 3, 1 by 3rd of the base. So it will be b by 3, that is equal to 3 by 3 equal to 1. Therefore this distance is 1 centimeters. Okay, so totally x3 is equal to 8 plus 1 equal to 9, and y3 equal to the height of the triangle divided by 3, 1/3 of the height, that is 4 by 3. This is y3 equal to 4 by 3, equal to 4 by 3. So that is the centroidal distances. Now x bar equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3, that is equal to, then what is a1? a1 is equal to pi r square by 2, because pi r square is the area of a circle, divided by 2 will give you area of a semicircle. So a1 is equal to pi r square by 2. We will calculate here. a1 equal to pi into 2 square by 2 is equal to 2 pi is equal to 6.28 centimeter square. a2 equal to 6 into 4 equal to 24 centimeter square, and a3 is equal to half into 3 into h equal to 6 centimeter square. Now x bar is equal to, a1 is 6.28 into x1 is 1.15 plus a2 is 24 into x2 is 5 plus a3 is 6 into x3 is 9 divided by 6.28 plus 24 plus 6. So this is equal to x bar is equal to, we will get x bar is equal to 5 centimeters. Then y bar equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So this is equal to 6.28 into y1 is 4 plus a2 is 24 into, sorry, here y1 is 2, y1 is actually, it is 2 because 4 by 2. So here also it should be corrected as 6.28 into 2 plus 24 into y2 is again 2 plus x3 y3 is a3 is equal to 6 into y3 is 4 by 3 divided by 6.28 plus 24 plus 6. So this will be equal to y bar. So y bar is equal to 1.89 centimeters. So this will be the answer. So we know the centroid of this complex area as x bar is 5 centimeters. So it will be here, okay, and y bar is 1.89, just below the center. This will be G, and G's coordinates are x is 5, 1.89. Now if there is a hole inside this area anywhere, we need to consider that also. Okay, so for that, how we will calculate? For the hole, we need to subtract the corresponding area and its product with the corresponding distance. That is how we will find out that area. We will solve one problem next.